Hello everyone. Today we'll be going through IGCSE chemistry and the topic is states of matter. This topic will be covering syllabuses of Cambridge, Adexel, AQA and Oxford. To cover this topic, you need to go through these three videos which are already available in the playlist, and this video is states of matter, another video which is mixtures of substances and diffusion, and the third one is kinetic particle theory of matter. You need to go through all three. Now if we see the three states of matter, everything around us is in the form of like gas, solid or liquid. So these three states of matter we can see everywhere, which is like in case of living and non-living organisms, we can see only these three which are there in your slips. Now we can understand that everything around us, like for example, ice, water and steam is made of particles, and this is known as like kinetic molecular theory of matter. So the difference between solid, liquid and gas comes down to how these particles move and stay together. So movement of particles, keep in mind, is very important, and how they are staying together is also important factor. So on the basis of this one, we will be studying in detail the different states of matter. The first one we will be discussing is solids. Solids, in case of solids, particles are packed together and they are closely packed in a fixed pattern also, and vibrate. They have vibrational motion, as we decided that we will be studying on the basis of motion of the particles. So in case of solids, they are having vibrational motion and they vibrate to and fro the fixed position, but they don't move freely. So they cannot leave their place, but they can just vibrate. We are discussing solids. So strong forces of attraction between particles also. Those strong forces are uh, keeping held together all the particles of the solid, and that's why they are having fixed shape and fixed volume also. So in solids, what we can say is particles are tightly packed and only vibrate in place. That's why solids keep their shape and cannot be easily compressed. Similarly, we can study the liquids also. In case of liquids, molecules are having gap relatively more as compared to this solids. Particles close together, but not in fixed position. So they are not in fixed position. They can slide past each other, so weaker forces of attraction as compared to solids. So that's why they are having fixed volume also, but they don't have fixed shape. They attain the shape of the container in which we are pouring the liquids. So it takes the shape of its container. So in nutshell, we can say that the liquids flow. The reason for flowing liquid is their particles are closed but can move freely, allowing them to take the shape of any container. Next one, if we study the gases, gases are having huge spaces among the molecules as compared to the volume of the actual volume of the particles. And they are occupying the space whatever available to them. So particles are far apart and move quickly in all directions. So diffusion of gases is basing on the spaces between the particles. So they don't have, they have like almost no forces of attraction, no fixed shape or volume in case of gases. So gases can be easily compressed and expand to fill any space which is available to them. So in nutshell, we can say that in gases, particles move rapidly and are widely spaced. That's why gases can be compressed and fill any container. So gases can be compressed, but very, very small volume they are having in between the molecules. So, but they have gaps more as compared to solids. Now we can compare basically the change of state when we are switching from one state to another. Like we know that states of matter are solid, liquids, and gases, and we can interswitch these states. And solid, if we are heating solid, we can switch to liquid, and liquid can be further heated to gas. Or we can cool gas to get liquid, and that's then from the liquid to further cooling, we can switch to the liquid state. So these are like interchange of states. So this is the change which is like a solid to liquid. We have to heat. That will be melting process. The process name is melting. An example can be ice, and ice converting to water. Similarly, liquid to gas will be boiling, or we can say evaporation. And this example is water is converting to steam. So liquid is converting to gas. Gas to liquid also we can convert, that is condensation, and steam converting to water is condensation. Condensation, we are cooling steam to get water. Similarly, liquid and solid can be interchanged. Liquid can be cooled down, like water is freezing uh, to solid. When we are putting water in a freezer, it's freezing to ice. So water is converting into ice. There's another process which is solid to gas, or direct conversion of solid to gas without first converting to liquid. So intermediate state, which is liquid, is not coming. So directly we can convert from solid to gas, and gas we can cool down directly to solid. And this process is known as sublimation. And examples are iodine and dry ice, which is carbon dioxide. So carbon dioxide gas, if we cool down, it will be directly converting to solid, and if we heat dry ice, which is a solid carbon dioxide, it will be directly converting to gas. So when substances change state, the particles do not change. This is very, very important. That, like for example, water molecule, we are having H2O, and H2O will remain H2O whether we are changing ice to water or water to steam. For all three states, the formula will remain same. Only the bonds, intermolecular bonds, will be broken. So only their arrangement and energy will change. And heating gives particles more energy, while cooling removes it. So hopefully you understand each and everything. We are done with the video, and don't forget to subscribe the channel. Thank you very much for watching. Take care. Bye.